Okay, so now we're going to look at number 2. So we just calculated the empirical formula. We're told that the actual molar mass is 110 grams per mole, and now they want us to find out what the molecular formula, the actual formula of this compound is. So the first thing we do is we need to figure out the empirical weight or the empirical mass of our formula. So what we have for carbon, we have 3, that's our subscript, 3 carbons, and each of those weighs 12.01 grams, and I'm going to write grams per mole actually instead of grams. All right, and then our hydrogens, we have 3 of those, and each of those is 1 gram per mole. And then oxygen, we have 1, and each of those is 16 grams per mole. Again, these guys here came from our subscripts, and these guys here, they came from our periodic table. Okay, so when we calculate those, we are going to end up with 36.03 grams per mole coming from carbon. 3 grams per mole will come from hydrogen, and 16 grams per mole will come from oxygen. And when we add all of these up, we will get 55 grams per mole when we're talking about our C3H3O. Okay, so this right here is our empirical weight, or empirical mass. All right, now notice the empirical mass and the molar mass are different. So what we do is we take our molar mass of 110 grams per mole, you divide that by the empirical mass, which is 55 grams per mole. And when we do that, we get this factor of 2. We're going to use that factor now, and we're going to multiply our empirical formula by our factor. We calculated to 2, so we're going to multiply everything by 2. So from our molecular formula, for carbon, we started with 3 in the empirical formula, and 3 times 2 will be 6, so we're going to have C6. Hydrogen, 3 times 2 is 6, so it'll be H6. And oxygen, 1 times 2 is 2, so it'll be O2. So our molecular formula is going to be C6H6O2. Now I want you to take some time, you can review these, and I want you to try numbers 3 and 4 on your own.